In this presentation, we are going to describe an innovative thermal network concept that we call the smart dual thermal network concept that can be used in order to upgrade conventional district heating systems to advanced district heating and cooling systems through the deployment of the absorption collector that Francesca has described us, the deployment also at the building level of an innovative building substation that we have created, and finally through the installation or deployment of an integrated district energy management system in order to provide model predictive control functionalities. So as you can see, this is not a new technology. This is more like a conceptual development that is partially based in some of the technologies that have been explained in previous presentations. So in this presentation, we will start by having an overview of the typical characteristics and the limitations of traditional district heating systems. After that, we will describe the main design characteristics and the advantages provided by the innovative smart dual thermal network concept. And finally, we will give an overview of the boundary conditions that are necessary in order to have a successful implementation of this smart dual thermal network concept. Okay. We start by summarizing some of the characteristics of the standard district heating systems. In district heating systems, we will have typically a district heating plant where the hot water generators are going to be deployed, and that will produce the energy that is going to be consumed in the buildings of the district. We will also have a thermal distribution network that will deliver the energy to the connected buildings. And finally, we will have the building substations that will connect the buildings with the thermal network, and that will take the energy from the thermal network so that it can be used in the buildings. In standard district heating systems, it is possible to have a demand aggregation of the demand of all the buildings of the district. And thanks to this, it is possible to reduce the nominal power of the generators installed in the district heating plant and produce better values of performance through higher values of partial load ratios. On the other hand, typically we will have low integration levels of renewables and CHP technologies at district plant and the buildings of the thermal network. And as Francesca explained before, typically the delivery of cooling, if cooling loads are present in the buildings of the district, is going to be solved through local deployment of conventional compression chillers or conventional heat pumps. Additionally, the control strategies of these district heating systems are based on reactive control strategies. And therefore, the operational status of the different systems of the buildings and of the district plant are adjusted according to the instantaneous evolution of the demand of the buildings and of the production that takes place on the renewable systems deployed on the buildings. In summary, what we can say is that buildings are seen from the thermal network as consumers that requires a variable amount of energy over time at a specific temperature and pressure conditions. Therefore, this kind of traditional or standard district heating system presents some limitations. The first one, and probably the most important one, is that the production of the locally deployed renewable systems and the locally deployed CHP systems is limited by the instantaneous demand of the buildings and by the available short-term storage capacity. And this normally reduces the local production of these systems and creates a suboptimal exploitation of these systems. As I said before, buildings play the role of consumers, and the thermal network the role of energy supplier, and therefore it is not possible to create any smart interaction between the buildings of the district and the thermal network. Additionally, there is not any, let's say, district-level cooling centralized production, and all the systems of the district heating system, I am referring to the district heating plant, the generators, the pumping groups, the thermal substations, and so on, are controlled according to reactive approaches. And finally, another very important technical limitation, according to traditional approaches, if we want to improve a district heating system to an advanced district and heating cooling system, it would be necessary to deploy an additional dedicated cool water distribution network in order to deliver the cool water to the connected buildings through and this cool water should have to be created by a specific additional cool district level cool water generation plant. So the implementation of these interventions would require a lot of time and would be extremely expensive. And for these reasons, typically it is very difficult to see district heating system upgrade according to these traditional approaches. So what have we do in order to overcome these limitations? We have created a new concept of a smart dual thermal network whose features are summarized in this slide. First of all, the energy that is necessary in order to have a heating and cooling, it's delivered through a single hot water distribution network that supplies the hot water to the buildings of the buildings, to the buildings connected to the thermal network. And additionally, as explained before by Francesca, thanks to the deployment of the innovative sorption collector, it is possible to produce locally at building level cool water using as primary energy source the solar irradiation, but also for situations in which the solar irradiation availability might be too low to operate the collectors at their nominal capacity, using hot water delivered from the thermal network. And this is why we call the thermal network concept smart, because this is why we call the thermal network concept dual, because we are producing or we are delivering heating and cooling, but we are using a single distribution network. So this is, from our point of view, this is a huge benefit, because it makes it possible to avoid the need to deploy an additional distribution network. Additionally, thanks to an innovative thermal substation model that we will see later, it is possible to aggregate also local production systems, and I am referring to renewables and CHP plants at district level, so that it is possible to establish a smart interaction between the buildings and the thermal network, and any production surplus that might take place in any specific building of the district can be delivered to the thermal network and used in other buildings of the thermal network, so that with this approach we can maximize the production of the renewable systems and the CHP plants that are located at a building level. And this is why we call the thermal network concept smart, because it allows this smart interaction between the thermal network and the buildings, and allows maximizing the locally deployed generation systems. On the other hand, as efficiency is very important, in order to have an efficient and economically feasible exploitation of this kind of thermal network concept, the hot water generation has to be always based, or almost completely, ideally completely, in renewables and CHP technologies. And additionally, as said before, thanks to the aggregation of the smart dual thermal substation that enables the bidirectional interaction of the thermal network and the buildings, we can aggregate the production of the CHP units that are located at the building level and we can create what we call a virtual district plant that can be controlled and operated exactly the same as we operate the heating plant of the district, thanks to this aggregation. And finally, as we will see later, in order to be able to operate this relatively complex thermal network concept, it is necessary to have an integrated district energy management system that can control in a coordinated way all the systems that are located in the district heating plant, the distribution network of the thermal network, the building substations, and the systems located at building level. Okay, so summarizing, the smart dual thermal network concept is based on the deployment of collectors in the buildings, on the deployment of an innovative thermal substation on the buildings, and on the implementation of an innovative integrated district control system in order to have a management of the complete system according to model predictive control approaches.